Okay. First thing is, Tom said he wanted to do one from the homework. Which one would that be?
Should be either 56 or 60.
56, 60. Okay, 56. Let's do 56. 56 says f of x equals cosecant of pi x over 6 x minus 3 in absolute values less than or equal to 2, and it says 2 if x minus 3 in absolute value is greater than 2. Okay, what does this say to do? Find the x values, if any, at which f is not continuous. Which of these discontinuities are removable? Okay, let's graph it. What does this mean? That means x minus 3 is less than or equal to 2 or greater than or equal to negative 2, right? Okay, so that means that numbers in between negative 2 and positive 2 I put into here. All right, so I mean, really, if you did not have a calculator, you could actually make a t-chart. And you could say negative 2, negative 1, 0, 1, 2 for your x's. And then I could say I have cosecant of pi times negative 2 over 6, which equals something. Cosecant of pi times negative 1 over 6 equals something. Cosecant of pi times 0 over 6 equals something. Cosecant of pi times 1 over 6 equals something. And cosecant of pi times 2 over 6 equals something. So, this is equal to the cosecant of negative pi over 3, which is really negative 60 degrees. So here we are, 60. This is negative radical 3, this is 2, this is 1. Okay, cosecant is hypotenuse over opposite. So this would be 2 over negative radical 3. Okay, yes or no? Is that what you got? Okay, this would be cosecant of negative pi over 6. All right, so negative pi over 6 is 30. So I have negative 1, 2, and I have radical 3 here. So what do we get here? Negative 2? What's the cosecant of 0? Okay, what's the sine of 0? 0. So that would mean cosecant of it would be undefined, right? Okay. I didn't hear what I heard, ones, and I heard all these different things, so I'm like, I don't know what they're telling me. All right. How about if we have cosecant of 30? 2 and cosecant of 2 pi over 6, pi over 3 rather, pi over 3. 2 over radical 3. Okay. Then what? Did any of you try to graph this on your calculator?
Yeah.
Yes? Somebody said yes. All right, so how would you put that in here? Does anybody know? Okay. I would have 1 divided by parentheses, sine of parentheses, pi times x, parentheses, divided by 6. I think I might need 2 parentheses this way. How many do I have going the other way? Okay, then I have to do parentheses, x is less than 2, parentheses, x is greater than negative 2. Okay. Okay. Then I have to put parentheses 2. This would be what? When x is greater than 2, okay, if you want to do that test stuff, you have to use test mode on your calculator, which is second math. Do you see above math, there's this word test? Okay, so we have greater than, second math, greater than 2, and we also have 2 if x is less than negative 2, right? All right, now, what I want to know is why they said 56 was continuous. What did they ask about?
Is this continuous? Yeah, it's the same thing. I think you might have grabbed it. Don't you dare.
Well, it says, well, all I did was put 2 in here, but I didn't do this. Yeah, this thing here is x minus 3 is greater than 2, or x minus 3 is less than negative 2, right? So this would be x is greater than 5, and this is x is less than what? 1? Okay, so we have to put in 5 and 1. See, this is the part I'm worried about over here. And this doesn't seem to make sense. Because if oh, that's why. All right, we have to do this over. We have to say this thing is x minus 3 is less than or equal to 2 or greater than or equal to negative 2. So that means x is less than or equal to what? This is 5 and this is 1. Okay, so that means I only get to pick things between 1 and 5. So I have to do this over and do 1, 2, 3, 4, 5. It really would be easier for you guys to just graph this. All right, let's graph it. I'll show you how to graph it. Now, on your calculator, you can graph piecewise if you didn't know it. Because some of you, I guess, didn't know it. Okay, first thing is, anything you graph in piecewise, you have to put in parentheses. Okay, so that's why here I have, the first thing is, I have parentheses 1 divided by sine of pi x divided by 6. And if you notice, I have 1, 2, 3, 4 parentheses that are on the left. So I'm going to have 1, 2, 3, 4 on the right also. Now, the next part is you have to tell it the section you wanted to graph. So I wanted to graph when x is less than 5. Okay? So x is less than 5 and x is greater than 1. Okay, now, the thing is, you don't want to put greater than or equal to because it puts these crazy lines in your graph. Okay, you just have to know that those are the spots you have to check, the 1 and the 5. Okay, you just have to know that. All right, now, the next part is when we did this, okay, for this one, we found out that x would have to be greater than 5 or it would have to be less than 1. So, you'll notice that even though I just have a 2, I put 2 in parentheses there. Because it has to know it's graphing that whole thing if x is greater than 5 or it's less than 1. I don't know if I can put both of them on one line. I really don't. I've always put them on separate ones. Okay, now, because that was a trig function, what I did is I hit zoom 6 trig. And it does the first part. And you notice that it connected everybody. Now, guys, if this one, if you look at this picture and you see it looks connected, if you look at this original function, you have to make sure one of them said less than or equal to. That would mean that the hole got filled in there. Okay? So, in this case, it did get filled in because the first one said x minus 3 in absolute value is less than or equal to 2. So that's the one that actually filled the holes in at the end. The other two would have had open ones that had been filled in by the first one. Okay? You could go through this without a calculator and use these values 1, 2, 3, 4, 5. And you would have had cosecant of pi over 6, cosecant of pi over 3, cosecant of pi over 2, cosecant of 2 pi over 3, and cosecant of 5 pi over 6. And you would have gotten a nice little thing, in fact, nicer than what we had to begin with. Okay? So you could easily graph that. Okay, now, and then the other two were just the ends going out in both directions. Questions again about how you graph this thing on your calculator. Okay, how about 60? What does 60 say? $60 was y equals 5 minus What does that mean? That's a stair step thing. So the minute you know it's a stair step, what do you know? Not continuous. You know it's not continuous. All right? You know it's not continuous. Where did the stair step guys, where were the discontinuities? At every integer. So that's all you have to write. You have to write that at every integer it would be discontinuous. Okay, now, if you wanted to graph that on your calculator, I'm going to show you again because there's still people who don't know how. All right, so I have y equals all right, we're going to say 5 minus, we're going to go math, go over to number, and go down to number 5, which is integer x. Okay, now, the thing is, though, this has to be in dot mode. So if you arrow all the way over to this, that's your style. And you can hit this, and it gets fat, skinny, or dotted. And then I could say zoom, and it's 6 standard, and there we go. We have a nice little graph of that. So we can see it. Okay, now, how about if they had asked you something like, number 63. F of x equals 3x squared, ax minus 4, x is greater than or equal to 1, x is less than 1, and the instructions say, in exercises 63 to 68, find the constant a, or the constants a and b, such that the function is continuous on the entire line. So how are we going to make that continuous? What has to happen if that's continuous? What had to happen with this one up here? Right, at the ends they had to be equal to each other, right? One had to fill in the other one. Okay, so that means at 1, these two have to have the same exact value. So I could say 3 times 1 squared has to be equal to a times 1 minus 4. They have to be equal to one another, because one of them has to fill in the hole that the other one's creating. Okay, so I have 3 equals a minus 4, or 7 equals a. Now, let's see if that works. If I put 1 in here, I get 3 times 1 squared is 3. 7 times 1 is 7. 7 minus 4 is 3. So they would both be equal to 3 at that place. One would be the hole, and the other guy would fill him in. And that's way it would be continuous. Okay, how about 67? '67 says f of x equals 2 if x is less than or equal to -1, ax plus b between -1 is less than x is less than 3, and -2 if x is greater than or equal to 3. So, in other words, what's happening here is, when we're over here at -1, we have this thing, we have 2, right? If I am over here at 1, 2, 3, Over here at 3, I am at negative 2. So something has to go on in between here that will connect each other. Okay, so these two have to be equal to each other when x is negative 1. So I have 2 is equal to a times negative 1 plus b. But at the other end, I have what? I have ax plus b, where 3 is in there, has to be equal to negative 2, right? So we have 2 equals negative a plus b, and 3a plus b equals negative 2. All right, now what do I do? How am I going to figure out what a and b are? Somebody has to answer me. This class has to wake up and talk. What do I do if I have 2 equations and 2 unknowns? Right, I could substitute one into the other. So I could say 2 plus a equals b, and then take this and put this in here for b. So that I would have 3a plus 2 plus a equals negative 2. So we have 3a plus 2 plus a equals negative 2. So I have 4a plus 2 equals negative 2. So I have 4a equals negative 4. So a is negative 1. Okay, seems reasonable, because what type of slope would this have to have? Negative slope. All right, so what's b equal to? Now we go back up here and we say 2 plus negative 1 equals b, so it equals 1. So now I have this equation here. I have negative 1 times x plus 1. All right, so let's think about this. If we were to graph that, right, I start at 1, and we go up 1 and over left, which is there, or I go down 1 and to the right, and down 1 and to the right, and down 1 and to the right. So that means that's perfect in between there. Fits right in there, doesn't it? All right. Now, what else are we going to be asked to do? Uh-oh. Numbers 69 to 72 say, discuss the continuity of the composite function. Okay. F of x equals x squared. G of x equals x minus 1. Guys, talk about f of g of x. Right? I would take g and put it into f. But let's talk about this first. Is this guy continuous? Is this guy continuous? Is this a composite function continuous? Yes. So if one of these has an issue, then the composite should have an issue, right? Okay, that's what you need to know. All right, let's see, what else do they ask me to do? Look at on page 80, look at number 79. 79 is the secant guy. it says, describe the intervals on which the function is continuous. So what do I say? What happens at 4? Sorry, what happens at 6? All right, let's talk about secant. Doesn't secant keep repeating itself? Okay, so aren't there going to be more issues? Okay. We know that at... Okay. Anything that makes this come out to be what? Let's start with cosine. That might be easier. Cosine of x equals 0 when? Pi over 2, and where else? 3 pi over 2, and these would be plus and minus, right? And they keep going on and on and on and on, right? Okay, so if this guy comes out to be pi over 2, then the secant's going to be undefined, and because if cosine is equal to 0, wouldn't secant be 1 over 0? Okay, so if this comes out to be pi over 2, or this comes out to be 3 pi over 2, then I'm going to have undefined. So there's going to be lots of these intervals. All right, if I go from, if you look at that thing there, if you go from -2 to 2, you're okay, right? Isn't it? All right. Then if I go from 2 to, what is it, 6? And then if I go, there seems to be an interval of 4 here. You see there's a pattern there? Because I would also have -6 to -2. So now we have to figure out a way to say that every time we hit that 4, after 4 little units, that we are undefined, or we are defined. Okay, so how are we going to do that? X cannot equal what? But we have to write it like a pattern.
2 plus 4. Every interval of 4.
Well, I know, but I'm thinking, couldn't I make a little formula?
So it's 4n. I think that would just be the integer now. 2 plus or minus 4n. If n is an integer. That's not the same.
Let's think about this.
Or it doesn't have to be plus or minus. It can be like -1.
Well, that's true. That's true. But if we said 2 minus 4, we'd get -2. If we said 2, but if we say 2 minus 5, it doesn't work. We have to say that these are what? Even? See, if I say 2 times, I'm just saying, we got to see if it works. 4 times 1 is 4. So 2 plus 4 would be 6. We'd be good. Now, how about if we put 2 in there? Okay, so are we getting them? Okay, then we're good. That's what you can't just, you have to say, and K is the integers. You know, and then you have to try it out. You know, you got to kind of, even if you just do it in your head, is it working out to be, because sometimes what happens is it doesn't work. You know, it works for the first one or the second one, but then it doesn't work for the rest of them. Okay, we have to say k is an integer. All right, now, there was something else that...
It can't be plus or minus because if you put in like -1, and that one.
Well, we're just going to say plus. But we are going to put in -1.
-1. If it's just plus.
Okay, if it's just plus. Okay. I cannot remember exactly what the homework was for today.
Page 91.
The review's your work. That's not your homework. The review is what I sent out so that you guys had something to do yesterday because we wouldn't have class time to do it. Page 80. 91 is... I sent that out yesterday. Or the day before.
I guess whenever you put your number on the board, I got your number, I think, but I didn't get, it's not coming up in your text. If I like send a text to you, can you add me to it?
I don't know how you do that.
Or how are you sending them out?
I'm sending them out through Reminder 101. You had to subscribe that day.
So we have not sent the answer review.
Review Friday, I'm grading it.
But we also have this assignment.
Yeah, this is today's homework. The review was yesterday.
Oh, but
I love that.
See, you have to put the at TRIGADV, right?
okay, hang on, the contact
All right, I need to talk 1 minute about the intermediate value theorem. All right, now, on page 77, it says what the intermediate value theorem is. Okay, it says, if f is continuous on the closed interval a to b, and f of a does not equal f of b. Okay? If f is continuous on the closed interval a to b, and f of a does not equal f of b, and k is any number between f of a and f of b, then there exists at least one number C in A to B where f of C equals k. Okay, now, here we are. We're on this interval. Here's A, here's B. We're saying that there's some function that's continuous, right? Here we are, we're continuous. All right, now, they're saying there's at least one place in here where if I evaluate it, I'll get K. Alright? Could be here, you know, at least one place where I have K. Alright, there's K. Okay, so our C would be right here. Or another C would be right there, right? This one wouldn't necessarily be here. They're saying there can be more than one spot even. All right, now, how could we use this to help us? Well, how about if I had something like this? And here's A, and here's B. If I knew that f of A came out to be a negative value, and f of B came out to be a positive value, could I say that this graph crossed the x-axis? Yeah. Would it necessarily have to be that A was the negative one and B was the positive one? No, it could be the other way around. So, that's the kind of question they're asking you on number... In exercises... In exercise 91 to 94, verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. Okay, so it tells me this. It tells me in number 91, it says f of x equals x squared plus x minus 1. We're in between 0 and 5. It says that f of C equals 11. First things first, I have to find out that f of A and f of B even exist, right? Okay, what's f of A? What's f of 0? Negative 1. F of 5, what is it? $25 plus 5, 30 plus 1, 31. Okay, now, f of C equals 11. So what does that mean? That means that... 29? Okay. I added instead of subtracted. Okay, I wasn't interested in that. I'm interested in the next part. This thing, what does this mean? It means that f of C is supposed to be equal to 11. So that would mean that C squared plus C minus 1 equals 11, right? Okay, so C squared plus C minus 12 equals 0. How do I figure this out? Okay, one person. How would you figure it out? Okay, factor. Does it factor? So C would be equal to negative 4, and C would be equal to 3. There's only one little problem.
C can't be negative 4.
Well, it could be both if this interval was a different interval, but this interval is 0 to 5, so which one is our value? Okay, so you shouldn't be having any problems doing this stuff that they're asking you to do. The homework I gave you just a few minutes ago. That's the homework.